Okay, so if you hear me, then I can start my presentation. Yes, again, the things that we know very much about from before, we are all experienced topography-guided transepithelial ablation users. But I just wanted to kind of emphasize how good this tool is and what we have at our disposal. So I would just make a little general look to it, and then about the evolution from PTK to transepithelial PTK to topography-guided transepithelial PRK. And then show a case of a quite complicated case that was treated so well with C10. So it all started with the PTK being the only therapeutic refractive surgery tool for many years, and we were treating just some superficial corneal dystrophies, recurrent corneal erosions, and the like. But
excuse me, Professor. Excuse me. We are not able to see the presentation.
I understand the epithelium and its function. And after the laser technology reached the necessary speed and precision to ablate such a big volume as epithelium, and after we gained more knowledge about the effect of corneal epithelial remodeling, then we started using transepithelial PTK, and in our case, immediately transepithelial PRK with our C10. So just a little moment about corneal epithelium issue. I know everybody heard about it thousands of times, but I think it never hurts to repeat the main issue, to have this main message heard again. So corneal epithelium is an active plastic layer which is always attempting to smoothen the underlying stromal surface to the maximum of its compensatory capacity. And this is the last part of the sentence, to the maximum of its compensatory capacity. It's very important because otherwise, if it had unlimited capacity, then all corneals would all. So that's why we have still irregular corneas. All the epithelial remodeling is contributing to improve the situation. So if the anterior corneal surface is irregular, we know that the stromal surface is even more irregular. So this is a kind of logical conclusion from the epithelial remodeling issue. And there's another one saying that corneal surface irregularity equals the stromal irregularity minus epithelial compensation. They're kind of Dan Reinstein's rule of epithelial remodeling. He dedicated his 25 years of his life to exactly this issue. So on the left side here we have anterior corneal section with the stroma.
Alex, can you hear me?
Hello?
Can you hear me?
Yeah, I hear you now.
We cannot. Do you have slides? Are you presenting slides? Because we cannot see your monitor.
Oh, you don't see? Why do you don't see my monitor? I will try it again. Come on, this is just not acceptable. Right? I go back there to here and try it again with the monitor. There, yeah, here we are. Please look at my monitor, because I changed those slides, so these are not good. Okay, do you see my monitor now?
Oh yeah, now yes. Okay.
Okay, good. Oh, I should have known that. Okay, so this rules of epithelial remodeling, and now we have on the left-hand side the anterior section of the cornea, irregular cornea with stromal surface and epithelial surface, and if we look closer at those surfaces, equal at all, and you'll see that the peak to valley distance on the stroma is much higher than the peak to valley of the epithelium because of the epithelial remodel, which is compensating the stromal irregularity to the maximum of its capacity. And on the right side, we have, thanks to procedure 2, a map of the anterior cornea, and then map of the epithelium belonging to the same cornea, and you can see that that epithelium is exactly corresponding with the stromal irregularity, or what we see here is the rest of the irregularity. Stromal irregularity would be even more, which we'll look closer to just in a moment. So, from a topography-guided PRK to transepithelial PRK, that is CTAN. So, traditional photorefractive keratectomy PRK with epithelial removal has also been used for years for treatment of decentrations and optical zone enlargements in other platforms fairly successfully. But it could not treat irregularities, or not any irregularities where significant epithelial remodeling occurred, because they would be concealed from the corneal topography, and then we will not be able to treat with the normal topography guided unless it's transepithelial. So in some cases, even there is an article that transepithelial PTK is better than a topography guided ablation for stromal irregularities. But of course, this is because they did not use transepithelial PRK or did not use CTAN, but removed the epithelium first, and of course they got worse results. So, bring us to the treatment issues which epithelial remodeling brings to us. What happens epithelium on, then we remove the epithelium, and then we have a stromal surface on which we treat. And definitely they're not the same treatment surfaces, even if the epithelium was regular, not to talk about the irregular epithelium. So doesn't the stromal surface on which the treatment is applied mirror the surface of the cornea covered by the epithelium? So we planned our ablation on one surface and applied to another surface. This is fundamentally wrong. So, what do we do with that? And we know the more irregular stroma, the more the difference. And to put some numbers of it, again, I use some slides I got from Giuseppe from Procedure 2, which gives us on the upper row the normal elevation or shunt topography, and on the lower row, it's stromal with epithelial electronically removed, which means that our epithelial map was removed from the anterior elevation map, and we got the stromal elevation map. And they look quite the same, this upper and down, but if you look at the numbers, we see the best fit sphere is much shorter radius on the stroma than on the epithelium, and the diopter change here is 4 diopters actually between the epithelium and stroma. If you look at how astigmatism is measured on the surface compared to the stromal astigmatism, we fitted a conic surface, and then we could see that the corneal astigmatism measured on the surface 1.28, and the measure on the stroma was only 0.28. Well, how come it's now smaller on the stroma? It's because this is definitely much more coma here. So the much more astigmatism was fitted into coma on the stromal side than on the after epithelial remodeling. So then some of the coma turned out to be astigmatism after epithelial remodeling. So definitely there is a difference. Usually it's more in the stroma, but in this type of keratoconus case where it is very pronounced coma, it will be actually some less astigmatism on the corneal surface. And after ray tracing and generations of refractive maps of Procedure 2, we could look at the asphericity and the higher order aberrations. And asphericity was -214 at the stroma, and -8087 on the anterior surface covered by the epithelium, which is a significant difference, and also the irregularities were much more pronounced on the stromal side. So this epithelial map, which is 39 microns concave epithelial lens, 39 microns thick at the center and some 78, 80 microns at the thickest on the periphery, is actually doing several things. It is reducing stromal stiffness and asphericity, as we see here, and it is smoothing the stromal irregular aberrations. So this kind of gives an impression how much epithelial actually means and how much wrong it would be to treat stromal surface by using our measurements with epithelium covering the anterior cornea. So traditional epithelial PRK in irregular astigmatism, again, to illustrate how wrong it is to do traditional epi-off PRK in irregular cornea. We take topography with epithelium on and we make our septal ablation plan. And then, before applying that plan, we remove the epithelium. And what happens, we have the stromal surface, which is much more irregular than the epithelium was. And if we apply on that stromal plan, we will end up with still significant irregularities. So this is definitely not the way to go. What we can do, what all people can do, not only IVIS user, is use the transepithelial PTK under the assumption that it's a good PTK which can remove some 70-80 microns, which most of the systems do not have. And if you combine that with topography guided PRK, we can achieve decent results. So the situation is as such. Again, we take our topography and plan our topography guided custom ablation plan. Then we program our PTK by using the thickest point of the epithelium. So we make sure that our lamellar ablation is comprised of both the epithelium, which is yellow, and the striped stroma, which is actually remodeled stroma, so that it shows on the surface as a headline shows. So if we use now, if we remove this, do this PTK, then we will end up with stromal surface exactly resembled the anterior surface covered with the epithelium. And then, of course, we can safely use topography guided custom ablation plan and achieve regularization. But of course, there's many practical issues here, and not everybody achieves that, but this is the right way to go, at least in theory. And now our system that we use with CTAN, it is transepithelial PTK combined with topography guided PRK into a single integrated no-touch ablation. So we take again our topography, we measure our epithelium in irregular cases, we should do that. We have tools to do that, especially in precision tool, there will be no problem. Otherwise, we must use OCT. And then we program our lamellar part of the ablation, which in SIPTAB it's called epithelial thickness. We program the epithelial thickness to the thickest point of the epithelium. And then we have a compound ablation consisting of two parts, both lamellar component and refractive component. And if we now apply this single integrated ablation to our cornea, it will be this way, and of course we will achieve regularization. Again, ablation rate difference between the epithelium and stroma may reduce ablation predictability, and that is something that we look forward to be addressed in the SIPTA2 system, which will take care of this issue. So once more, CTAN, transepithelial PTK, and topography guided PRK, this is the upper part, although we reverse when we apply it, we all know. And we have a single continuous ablation that regularizes the stromal surface. So this is the red line is the stromal surface, all this underneath is stroma. So this is our new surface that will occur in this irregular case. So this is all to explain the background for our case report. It is a very special case. So LASIK during holidays in India in 2012. He's almost on his sphere, 375 right eye, 4.5 left eye, and this is the left eye. And, after several attempts of removal, we had retreatment which caused the persistent scarified epithelial ingrowth in the left eye, and after several attempts of removal, it just persisted. And it was referred to me in January 2015 with decreased visual acuity and visual disturbances, and this cornea looks as terrible as this. And the many scars, maybe they don't appear so much on the slit lamp photo, but it was actually absolutely no question of lifting the flap and doing something like that. But fortunately, this cornea was quite thick. So this is what our OCT showed. It was actually two flaps here, and the epithelium scars in between, and just a whole mess. But the only good thing is, but the nice the residual stroma underneath. If we remove all this mess with our CT. So here our refractive data also just as terrible. Like here we look at the 1175 abarometric astigmatism, and depth of the ingrowth was 265, or depth of the scars. At 6 o'clock, 2 to 3 millimeters from the vertex. This was the maximum part. Objective refraction, 11 diopters. Astigmatism, corrected visual acuity, 0.2. And wavefront aberrometry, 3.85 RMS at 5 millimeter. Mainly consisting of odd order aberrations, which were 379 out of 385. This is our procedure, and fortunately the posterior did not matter so much in this case, so we just don't look at it because it's very much affected by the scars. No sign of biomechanical failure seems to be, and this is our pachymetry map, shows ample tissue, especially in this area that we want to treat. And so we went further and acquired our OCT map to compare those two, and they were agreed quite much in most of the measurements. And then we went and defined a problem, which was the visual vision due to high order aberration, irregular astigmatism, and reduced transparency. So we wanted to improve the transparency and to regularize the cornea. So regularize the cornea optics was the first thing we wanted to do to improve the visual vision and to remove the scar tissue of the degenerated epithelial ingrowth. How? Design transepithelial topography guided CT, comprising both the flap and the ingrowth, and the epithelium, of course. So flap lift was not considered due to the scar tissue, had enough residual stroma tissue underneath the ingrowth. So this is a next thing to show how we go around it. So we imported the case to SIPTA, and of course use our iris laser, and we assisted by data from the epithelial and scar thickness data from our OCT, in order to get the numbers right, to know how deep we want to end up. So as you could see in this plan, I went for the optical zone of 725. Why? Not because I wanted to get some excellent undisturbed vision, but because I needed that to get deep enough. So this wide optical zone gave us a deep ablation also, which I would rather have use ablation to be deep than to increase the epithelial thickness too much, because we always get warning on CTAN. Don't change microns, or the change will induce some problems. Anyway, so then we go into iterative process. But by looking at our ablation plan, looking at our pachymetry, and looking at our epithelial map, in most cases, this case the epithelial map was not so important because the scar was much deeper than the epithelial, so we wanted to remove all the epithelium anyway. So we can see here, we look at the minimum pachymetry place. It was here. This was for 527. And we looked at it coincided, we look at the coordinates, and we look at it coincided with our ablation depth of 98 microns in our current plan. And that gave us 438 rests, 31 rests, which was satisfactory. We thought this was good. Then we look at the next place, maximum ablation depth. We look at here. Where does it happen on the pachymetry? And then we look, fortunately here, the pachymetry was 664 at a place where ablation depth was the max before. And then it was 380 micron stressed, which was also satisfactory. And then epithelial thickness was not so in this case, it's all epithelial thickness, not in any case. So this is our SIPTA plan, transepithelial tomography and OCT assisted SIPTA ablation plan. Actual ablation, refractive ablation was enough. We added here, let's see, 82 microns, moved the epithelium and the scar. So then we total ablation maximum 41 at point already, and it means this should be safe. Here is 416 residual, but it was with 6 epithelium of 54. So this. So again, 159, and this is what we've got. It's actually 1.5 years after planning, because the patient was from far away, so he gave evaluation 1.5 years later. So corneal OCT shows that the epithelial ingrowth and scar were and removed. So refraction 6 0.02 and vastly improved. And the wave from the barometer 8. So our new procedure showed segmentation and energy index of 47. No, it's not as normal, but it's nice. So the necessary measurements and methodology. Oops, sorry. Presentation, posterior corneal things, great cognitive, lenticular restriction, just a guide, not some program or treatment. Use it as a guide to have an idea what to do. And of course, the corneal epithelial map, which in this case was not so important, but it is in most of the regular rare cases totally inevitable. So that was this presentation. And thank you.
Thank you, Alex.
Thank you.
Any question for Alex? So, Alex.
Yes?
Actually, we want to thank you for your contribution and be in touch by tomorrow.
Good, good. So what time tomorrow do I connect?
We will start at 9 o'clock tomorrow.
Okay. Okay, then I connect at 9 o'clock. Okay, good. Thank you. Thank you very much. Have a nice evening.
You too.
Thank you.
I guess